Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying the session. We are enjoying a lot. We are learning a lot. So hope the same thing for you guys. If you guys have any doubts, just ping us in the comment section. We will take up and we will solve your doubts. Okay, we are here to guide you, help you, and then mentor you. That's a major task for us. So yeah, today's session is all about the coding part of LDA. So for the past two sessions, we have gone through the theoretical concept of what is LDA, and then mathematics begins the LDA, black box begins the LDA. Make sure you guys watch those videos so that you can have a better understanding of this coding part of this LDA. But for me, you guys need to learn or make sure that you guys watch all the previous session videos so that you guys have a continuation of what we are talking. Okay, without wasting any time, let us jump into today's session. Okay, so today's session is all about coding part of LDA. Let us start. Okay, first thing guys, this ID, right, this is a collab ID. So if you guys have watched our Python programming course, sorry, Python programming session, you guys are able to understand what is this collab. We have an end-to-end session there. We have explained you about this entire interaction of how collab works, what is collab, how to load the data set to the collab, how we can work on the collab, everything we have done that. So make sure you guys watch that video so that you can have an understanding of this collab ID. It is sponsored by this is given by the Google. Okay, this is a Google ID where we can run the Python. Okay, now let's move for the session. Okay, LDA coding part. Let's hope if you guys have watched our videos, we have done nearly 10 plus coding sessions. Then it becomes memorized for you guys if you have watched all the sessions. Okay, let's move on. So I'm going to import the necessary libraries, NumPy for doing the mathematical operation, whereas pandas in order to treat the dataset in a form of a data frame, and matplotlib.pyplot as PLT. I'm going to use for the visualization, and then I'm just loading the inbuilt dataset, that is iris dataset from sklearn library. I hope you guys are well versed with this toy dataset of iris. Okay, now next thing is pre-processing. I'm just using the standard scalar, and then from sklearn discriminant analysis, I'm just importing the linear discriminant analysis as LDA, and then I'm just using model selection train test bit. That's it. Now I'm going to load my dataset, that is iris dataset. My x is my input, that is iris.data, and my y is my iris.target. That's it. Okay, so this is what the entire dataset you guys can see here. Okay, we are having 4 different values, and then we are having a target value of 0, 1, 2, and then these are the target variables, and then so these are the description about it. I hope you guys know about the dataset, right? What is the iris dataset? We will be having the sepal length, sepal width, petal length, petal width. Based on that, we're gonna find what species it is, whether it is setosa, vesicolor, or virginica. That's it. Those are the flower names. Okay, so I hope I think this is the 5th time we are using this dataset. I hope so that's the reason I don't think you guys need a proper introduction about this dataset. Okay, even though I'm just giving. So we will be having a flower kind of thing, and we will be just calculating the sepal length, sepal width, and petal length, petal width, which class it belongs to, which species, whether it is a setosa, vesicolor, or virginica. Hope you guys can able to understand. Okay, moving on. Let's this is my x. So sepal length, sepal width, petal length, petal width, and this is gonna be my y. So we're gonna have the species here. I'm going to summarize my dataset. So I'm just passing my input x and then my columns, iris.features. I'm going to have the data frame. df.describe, it's going to describe, give the descriptive statistics about the dataset. We will be having a count, mean, standard deviation, mean value, max value, 25%, 50%, and 75%. Like you can see for all the columns we are having 150 is a count, that is 150 records we will be having. So mean value, max value, you can see. So this is the descriptive statistics. When I print the shape of it, you guys can see here, we are having 150 records, 150 rows, and 4 columns, that is 4 features. Now, I'm going to do the pre-processing. So I'm going to import standard scalar. I hope we have imported standard scalar, right? So let's see, through the pre-processing step, we have imported the standard scalar. Okay, we are having pre-processing, right? From that, I'm just importing standard scalar, and then here I'm just defining it. That's it. Okay, you guys see here I'm just defining the standard scalar. Okay, and the variable to the scalar.fit transform of x. So I'm gonna get the scaled value. Okay, now you guys see here the values are nearly -2 to 2. Before that, we are having the value in the range of, here you can see there is a 2 digit 4.8, 5.8, like that we are having, but here you can see 0 point values. Okay, we are having a 1 digit value and also 0.1 digit values. Okay, so there are different range, right? 0 point values and then 5-point values, 3-point values, 2-point values. So we're going to make everything as to the standard scale, that is -2 to 2 when we apply the standard scalar. Okay, hope you guys can able to understand. Here you can see this is what once we have applied the standard scalar. Okay, now I'm going to split my data set to input and output. Standard scale, that is after standard scale we are having the data, right? That is called as X scale. My Y is my output, and this is my test size, which is 0.3, and my random state is 42. Now this is what earlier we are having X dot shape and Y dot shape, which is like nearly 150 records and then 4 columns for my training, that is my input, and my output is like I will be having only 150. After doing train test split, we are having 105 records for training and 45 records for testing, because like we have done the 70:30 split, right? That's the reason. Now I'm gonna load the LDA. Okay, what I'm gonna do means LDA number of components is 2. Okay, we are having 4 components, right? Sepal and sepal with, petal and petal with. Is it right? So we are having 4 columns. We're gonna make it as only 2 columns. So here, once I done it, I'm just passing this LDA variable, LDA.fit transform of, I'm having my X train and then Y train. Guys, see here, we are having input X train, Y output as Y train, because LDA is a supervised learning, but it comes under the dimensional detection. But previously we have used PCA, right? Coding session. We have just passed only the input. But since the LDA is the supervised learning technique, we are using both input and output. That's it. Okay. And you guys see here, we are having only 2 dimension. Okay. Now moving on. So this is my X train. So let's see. This is my X train. For every training, we will be having 4 values. So now we have converted everything only to 2 features. Okay. Now moving on. Let's see the explain ratio. LDA dot explain variance ratio. You guys see here, for the first column, that is LDA1, we are having 98% of information retrieval. Whereas for the second column, we are having nearly 0.01, that is 1% of retrieval. Okay, hope we have get nearly 99% of information gain. Okay, even though we have done a LDA and just reduced the dimension from 4 to 2, we got 99% of information retrieval. No problem. It's great. Okay, we can have 0.1%. Okay, no problem. 1% of information not retrieved is not a problem. We are getting 99%, right? So with only 2 dimension. Okay, so this is my Y train. I'm gonna plot the figure. X LDA of 0 first dimension, this is second dimension. I'm just giving the color as Y train. That's it. So you guys see here, X label, I'm just giving the first LDA component, and Y label is second LDA component. I'm just plotting the LDA of iris dataset, only training set. You guys see here, we are having first LDA component, second LDA component, and we are getting 3 things. Okay, Setosa, versicolor, and Virginica. That's it. Okay, this is what training set. I'm going to do the same thing for the test set. I'm going to apply the LDA dot transform to the X test variable. This is test of LDA, only 2 dimension, and we will be having X test, which is 4 dimension. You can see 1, 2, 3, 4. And once we have done this, I'm gonna print X test, and now I'm gonna plot it for the testing data. This is X test of LDA, X test of LDA. We're gonna have 2 dimension, 0 dimension, and then 1 dimension. For color, I'm just using this X test, sorry, Y test. That's it. So I'm gonna plot in the this Y test, and then I'm gonna plot first LDA component in X-axis and second LDA component in Y-axis, and then this is the title, like LDA of iris dataset, but for test data. I'm going to show it. That's it. We are having the first LDA component, second LDA component, and this is LDA of iris dataset. That is for test set. Okay, we are having Setosa, versicolor, and Virginica. Okay, hope you guys can able to understand. Okay, what we have done here, LDA, by using LDA, we have reduced the dimension of the 4-dimensional data to 2-dimensional data, so we are able to visualize it also. Okay, 4 dimension, I don't know, we can visualize, no problem. But like, so the thing is, it's a toy data set. Consider we are having 1,000 dimension, we are just reducing to only 2 dimension in order to make the visualization. Okay, hope you guys can able to understand. So this is what all about the coding part of LDA. Okay, so I hope like sir is gonna have some more insight on this coding part. Okay, so yeah sir, over to you.
So yes guys, if you've come to this session, go watch all the previous session 5 to 10 times to reinforce learning, build a long-term objective function, and process the information, digest and apply. Mimic this model, this project, and this and imitate it, and write in the comment section how you're feeling, what is your feedback, how we can improve these models and these sessions. So let's move to LDA, Linear Discriminant Analysis. So guys, simply I'll tell you in simple terms, it discriminates two classes, keeps them separate. Like politicians, they want to keep two communities separate and they will do their politics. Same way, linear discriminant analysis does the same way in application. Like they want their groups, they want their vote bank like politicians. Same way, linear discriminant analysis will keep classes separate and separability, so that is good for data because you then you have the information which is not getting mixed up. Okay, so that itself is a it has trade-offs, like in politics also and in data also. Ultimately, even politics is data, everything is data. So let's move. So first, we have to import libraries, which is NumPy, Pandas, Matplotlib, data set. We have to import pre-processing, standard scalar. We have to linear discriminant analysis, LDA. We have to import it and train, test, split. So step 2, using the iris dataset, we'll use the iris dataset. Okay, iris equal to load iris, x and y, iris data and iris target. So then we have the output. Iris data is features, iris target is label species. Let's move to the, this is the output. You can see big output with a lot of data, and target you have, yes. So then you have X variable, it's very big also. So then we have Y, you can see, and then we have summary of it, which is df equal to pd dot data frame. We have X column iris feature name, print data summary, and df dot describe print data set shape, df dot shape. So you have the shape and you have the summary shape. You can see 154. Then we have to do pre-processing of the data, scaling the features before applying LDA, scalar standard, S scaled, scalar dot fit, transform X. So you, and then you have to print it, first 5 rows of the scale data, okay, n x scale 5. So these are the first 5 rows. Then you have step 5, splitting data set optional for train and test purpose. And then this is the shape x and y. X train shape, X test shape, Y train shape, Y test shape, 100 for 45 for 105 45. X shape, Y shape, 150 for 150. Okay, then you have, yes. So then you have step 5, step 6, applying LDA. We have to LDA equal to LDA and component 2. So that is the principal component 2, right? And X LDA dot LDA fit transform X train Y train. So X LDA, you will see this is the array, this is the data of output. Okay, let's move. X train, this is the output. And let's move to, yes. Then we have the LDA component, the ratio, which is explained variance ratio, which is 98. A Y train, that is the output. Step 7, visualizing the LDA results. First LDA component, second an LDA iris dataset training set. Okay, data set we have to see. This is how it looks, first and second LDA component. Okay, and the iris data training, and let's move. This is the visualization of it, and then transforming data set and visualizing optional X test LDA equal to LDA dot transform X test. This is the array, this is the output. And let's move to the X test. Again, this is the output. And this is the Y test array. Then we are going to plot it, and then we'll do plot figured, plot scattered, X label, Y title, first component, second component, and data set. Test. Okay, for test we'll do same. This is the visualization, first LDA component, second LDA component for the test. This is different, right? You can see there is difference. Okay, let's move. You
Yeah,
can
that's it.
visualize and see for any data. That's it. Keep learning deeply, guys, with long-term vision for your lifelong learning vision. Keep learning. Thanks.
Yeah, guys, so this is all about today's session. So today we have explored the coding part of LDA. Hope you guys have understand. If you guys have any difficulty in this, anything that is doubt for you, just ping us in the comment section. We will take up and we will solve your doubts, because like we are here to help you. Okay, so guys, that's all about today's session. Make sure you guys watch this session clearly. If you guys have any doubts, as previously as I said, just put it in the comment section. We'll take up, we will solve your doubts. So yeah, guys, until next session, bye guys, take care. We will all meet in the next session. Bye guys.